gravity of the Earth, and based on the relation between the axis of the gravity of the Earth and your body, it's known that the way it's positioned on the body, the x-axis of the accelerometer is pointing up. So if the x-axis senses gravity, which amounts to 1.6 volts, then the command station detects that as you're standing. So it basically only detects if you're standing or laying. It doesn't do anything.
So it's not a dynamic thing. It's
No.
a static thing.
Yeah.
It measures gravity, and depending on which one of the three axes is sensing the gravity, you can determine position. Okay.
Madam Director.
I was wondering how you guys, I mean, you said you use this on for firefighters. I was just wondering how this would work if it malfunctioned entirely. And I mean, is it like heat-proof, fireproof, something like that?
It's not fire retardant, but actually what we have built into the microcontroller algorithm, we have that irregular state. So pretty much what that's going to tell us is that since the pulse oximeter is measuring two vital signs, let's say it's not on the skin at all times and it starts giving us false readings. We're going to take a look at the other vital sign data and figure out if those are in the normal ranges for what we want him to be doing or what we think he's doing, then we'll pretty much say that sensor is not functional. But in terms of being sweat proof, most of those sensors are, the pulse oximeter is tolerable to that. And some of the sensors like the respiratory sensor, we're still working on trying to shield that. Currently we'll have that ready for Friday. The thermistor is waterproof as well.
Plus, let us mention that this vest goes directly on your skin, so whatever protection that firefighters usually wear for fire or anything like that goes over the vest. As well as people in combat, will have Kevlar over this, or police will have the bulletproof vest over this. So this is directly on the skin. Everything else goes over. So they're responsible for their fire retardant equipment and
You mentioned that the biggest cost was software.
Yeah, actually.
What software was it? Was that on the
National
station?
Instruments Measurement Studio, that's what creates all the graphs and stuff. It's rather than spending time to
In
code.
LabVIEW?
Oh, LabVIEw?
Yes, sir.
Oh, well, LabVIEw.
Well,
Wasn't it?
it's not LabVIEw, no.
It was Measurement Studio. I'm
Yeah,
pretty sure it was Measurement Studio.
it's the parent company of LabVIEw, National Instruments. It's their package they create for Visual Studio. So it's a toolbox that integrates into Visual Studio. So you have LabVIEW-esque, graphics, but you can implement them into a .NET-based programming environment in Visual Studio.
This software was running on the command station?
Yeah. Rather than trying to have Visual Studio has the capability of drawing graphics, but drawing something like as complicated as a graphic just takes forever. So, plus it'll be extra processing power for the computer.
Turn the record.
I was gonna ask how many vests can the command station monitor? Do you guys know like the map? Because we've seen 4. Do you know how many?
Well, we only have one unit right now, so. But yeah, they could scale up. The,
Okay.
the radio has the ability to do multi-point, communication.
Okay, that's cool.
So it's scalable.
Are there any existing commercial products, and how is your design superior or different from them?
Actually, there's a couple of them. NASA actually uses a similar vest for their astronauts, but it's actually more like a belt that goes around your waist here, and they monitor astronauts in space. I think there was a group from Georgia Tech University that built a vest that could monitor bullet penetration with using optical fibers to do that. So there's several similar vests out there, but one like ours, we haven't really seen something that's fully integrated with the number of sensors that we have, being able to monitor it with an external GUI remotely like we have.
There's a group in town building something similar that also monitors hydration levels. Because apparently people out in the field don't hydrate properly and they get sick. And they've been losing some rangers that way.
Probably meant
Yeah,
about
how's that?
sweat rate.
No, they actually have a water bottle. They monitor how often they sip water.
Nothing so fancy, right?
I figure if they're dehydrated, then they can run the risk of heat stroke, which
That's right.
the thermistor can sense.
But then it's too late. They're in trouble. You want to get them.
Let's recognize Kevin Priest from Cubic who sponsored this project. Thank you.
That concludes our presentation. We thank you. Please come to Design Day. I would like to show off, my hard work and hopefully my abstract abs and everything. So hopefully we'll have a good Design Day. Thank you, ladies and gentlemen, for coming. And thank you for coming to